You ever notice how weather used to feel kind of predictable, like it had a routine, even if it was a slightly annoying one, like, oh, it's hot again, or it's probably going to rain later. But now it feels like the atmosphere is just randomly selecting difficulty settings every week, and nobody really remembers when that change actually happened. Because it's not like there was a clear announcement like, starting this year, weather will now include occasional disaster events. It just gradually shifted into this thing where normal days feel suspicious and extreme days feel normal. And the interesting part is, if you ask for an explanation, you usually get something like greenhouse gases, trapped heat, energy imbalance in the atmosphere, which is technically correct, but also feels like the kind of explanation you give when you don't want to explain the actual uncomfortable version of what's happening. Because at the most basic level, Earth is just a giant energy system receiving constant input from the sun. And historically, that energy was distributed through air, water, and land in patterns that were chaotic, but still stayed within a certain predictable range that human civilization basically evolved around. The key word there is range, because weather doesn't need to be stable, it just needs to be stable enough. But what starts to matter over time is what happens when that range expands. And that's where things quietly start to feel different, even if no single day looks completely abnormal on its own. Because systems don't usually break by suddenly becoming something else. They break by slowly stretching what normal even means. Now the atmosphere is not just receiving energy from the sun, it's also retaining more of it, especially through greenhouse gas accumulation, which means more heat is staying trapped instead of radiating back into space. And that extra stored energy doesn't just sit there politely. It gets distributed through winds, ocean currents, evaporation cycles, and pressure systems, basically amplifying whatever processes already exist. So instead of weather becoming a completely new system, it's the same system, but with more energy flowing through it. And in physics, when you increase energy in a dynamic system, you don't get smoother behavior, you get more volatility. It's like turning up the speed of a machine that was already slightly unpredictable, and then acting surprised when it starts producing more extreme outputs, instead of just faster normal outputs. But here's where it gets interesting, because what most people intuitively expect is that everything should just get uniformly hotter or slightly more intense. That would actually feel easier to understand. Instead, what happens is that the distribution changes. So you don't just get hotter average days, you get more separation between extremes. The middle range starts shrinking, while both ends of the spectrum expand. That means fewer normal days and more, this feels unusually intense in one direction or another, days. And that's why it feels like weather is getting worse, even when technically it's just becoming more uneven. Because humans don't actually perceive averages very well. They perceive deviations from expectation. So even if the average change is gradual, the spikes are what stand out. A heat wave doesn't feel like a statistical shift. It feels like reality breaking its usual rules for a few days. Now add oceans into this system, because oceans are basically the planet's heat storage unit. They absorb massive amounts of energy and release it slowly, but when they retain more heat over time, they start feeding more energy back into the atmosphere. That leads to stronger evaporation, which means more moisture in the air, which means when conditions trigger rainfall, it can become significantly more intense than what older baseline conditions would have produced. So instead of slightly more rain, you get situations where rainfall events are more concentrated and more extreme. And this is where things start stacking, because warmer air also holds more moisture, which further increases the potential intensity of storms. So now you have a system where heat increases moisture capacity, moisture increases storm potential, and storms redistribute energy again. That's not just change, that's feedback. And feedback systems are where predictability starts to degrade. Because once a system starts reinforcing its own extremes, it becomes less about steady progression and more about oscillation between stress states. So instead of smooth transitions, you get sharper swings between conditions that feel comfortable and conditions that feel abnormal. Another thing that adds to the perception shift is timing. Weather events don't just have to be stronger to feel worse, they also have to be less predictable. And as variability increases, even if total yearly averages don't look dramatically different at first glance, the timing of events becomes more erratic. So seasons feel less defined, transitions feel less gradual, and expectations stop matching reality consistently. At that point, the problem isn't just intensity, it's loss of reliability. because humans and ecosystems both depend on predictable cycles, not perfect ones. Agriculture, infrastructure, water systems, everything is built around expected patterns of temperature and precipitation. When those patterns shift even slightly in distribution, the system-wide effects compound in ways that aren't immediately obvious from a single weather report. And this is where the uncomfortable part comes in, because there is no single switch that defines when things became worse. It's not like weather crossed a threshold one day and suddenly changed personality. It's more like a continuous adjustment of baseline conditions that only becomes obvious when you compare memory against current experience, which is always a bit unreliable because humans normalize whatever they live through. So when people say, weather feels worse now, they're not imagining it in a simple sense. They're reacting to a system where extremes are more frequent, variability is higher, and the middle range is shrinking. And once a system starts favoring extremes over stability, the perception of normal weather naturally starts disappearing, even if the underlying physics is still governed by the same basic rules it always was. And that's basically the core idea. Not a broken system, not a new system, just an old system running with more energy, less predictability, and more frequent excursions into states that feel abnormal, compared to what humans historically adapted to.